Hey guys, we are going obviously back into trig. I mean, you may need to watch this video twice. I actually may want you to do it twice, but so let's see what we can remember. So this stuff may seem a little weird because we haven't done it in a little while, but I think we'll catch on pretty quick. So essentially, what we're doing today is just going to be graphing sine and cosine. Normally, it's a lesson where we graph all six trig functions, but really, we're just going to worry about sine and cosine for this week, and I mean, really for the whole year. And that's okay. So when I think of graphing sine and cosine, right, we kind of see this graph here. Um, it goes 1 2 3 4 5 6 7, but it also labels some things in here like 2 pi and pi. Like pi is 3.14, so you can see it's a little after 3. A half a pi or pi over 2 is like 1.57, so it's like in between 1 and the 2. This is where 3 pi over 2 is. This is where 2 pi is. It's good, I think, on a lot of the work. I put those on there for you guys, and a lot of times that's all that you need to pay attention. You don't need to pay attention to the numbers and things like that. So I would, if you're printing out regular graph paper, I think that's great too. Um, just you might want to put where these things go so that it's easier to graph them when you do need to graph them, right? So we're going to look at y equals sine x, right? So these are all my x values. I've just pre-filled some of them out. We're not going to do all of them. It's going to take too long, and it's kind of, you don't really need it. But um, what I'm going to do is, like, if we looked at 0, right? So we're going to use this unit circle and just say, all right, sine is the y coordinate, right? So if I look at 0 pi, I know that the angle of 0 pi radians, is right there. So sine is the y coordinate right there. So the y coordinate right there is 0, right? Um, so I plugged in 0. I got 0 on my graph. That's 0, 0. And that's it, right? So the x-axis is the angles that you're plugging in. The y-axis is the outputs, right? So you don't need the pi's and stuff like that over here. You're not going to get pi really, but you do need them on the x-axis. So like pi over 6, we could do that. Pi over 6 was like 30 degrees. The y-coordinate right there is 1/2. So, we can put that one on there. But on my graph, I don't really see pi over 6. It's like pi over 2 is here. Where the heck is pi over 6? If you think of pi as like 3 over 6, it's almost like it's a little bit bigger than 1/2, 1/2. But I don't really care about this. I'm just going to worry about the ones that I see, and then I'll show you how it connects. So even pi over 4, it gives me root 2 over 2. You know, somewhere over there is pi over 4. What is root 2 over 2? Maybe I don't know. Don't worry about it, right? The one I am going to worry about, like now that we get to pi over 2, like these are, that's back up to 90 degrees. We're going to look at that one, right? So pi over 2 is right there. And the sine of pi over 2, which is the y coordinate right there, is 1. So when I plug in pi over 2, I get 1. So right here, pi over 2, I got 1. Again, I'm going to skip some of these. I'm just going to go to the 90-degree ones, just to keep this going pretty quick. So pi is going to be over here. That's the next one I have right here is pi. So if I think about pi, which is right here, again, I'm looking for sine of pi. The y coordinate right here is sine. So the y coordinate is 0. So when I plug in pi, it'd be my kids banging something. When I plug in pi, I get 0, right? The next spot I have is right here, which is 3 pi over 2. Where is 3 pi? Okay, right here, 3 pi over 2. So when I do 3 pi over 2, the y coordinate right there is -1, so sine is -1. So right here I have 3 pi over 2. I go down to -1. And then I have 2 pi again, which is the same exact spot as the 0 pi was. So it's going to have the same sign, right? The same y coordinate, so it's going to be back to 0. So 2 pi, different input, same spot, same output. And if I wanted to do negative angles, I certainly could, right? So like if I did negative pi over 2, just remember negative angles go clockwise. So negative pi over 2, which is right here, that's going to be -1. So if I plug in negative pi over 2, I get -1. Negative pi is going to be right here, so the y coordinate is 0, so sine is 0. Negative 3 pi over 2 would be if I came all the way back here. Y coordinate is 1, so I'm going to get a positive 1. And you can kind of see how all of this stuff, negative 2 pi would be all the way back around, same spot, the y coordinate 0. You get this, right? So the curve is, if you connect these points, and it's not like with sharp lines, it's kind of like curvy lines, right? But essentially, you're going to get this sinusoidal wave, right? And sinusoidal is kind of just like the adjective for like a wavy line, which happens with sine and cosine, right? This question asks me here, what is the y-intercept? The y-intercept is 0, 0, right? And that's always true for sine. And that's essentially how you would graph sine, right? And this is like your parent function as we go further in the week. So you're going to want to be pretty good at this very quickly. So that's why I said, if you want to do it again, just you don't need all these points. Just think, all right, 0, pi over 2, pi, 3 pi over 2, 2 pi. Just think the unit circle once around both ways, positive and negative, and like you get these points by just plotting those ones out. And again, you don't need to plot everything in between, like the ones we know, like the 1/2s, the root 2 over 2s, the root 3 over 2s. Just do every 90 degrees, and you'll get that same shape. And so the other one, right, and we do it in groups if we were in class. If you want to pause the video and try cosine of x on your own, I'd say great. I'm going to go through it anyways, but if, for some of you independent learners, by all means, go ahead, pause the video, and just check it when we're done. What I'm going to do is same thing. I'm going to draw my own little unit circle over here. And now I'm looking for cosine, which is the x coordinate, right? Cosine is the x coordinate. So I'm still going to plug in all of these angles, right? And again, they're all in radians. We're not really dealing with degrees. So I'm going to say 0 radians, pi over 2, pi, 3 pi over 2, and 2 pi. Those are all the positive ones. So, I'm just going to say 0 radians or 0 degrees. The cosine is the x value. So the x value right there is actually 1. So the y-intercept, it's 0, 1. It's a little bit different than sine, right? 0, 1. Pi over 2, right? Pi over 2 is still the same spot, but the x-coordinate now is 0, right? The y-coordinate's 1, but the x-coordinate is 0. So pi over 2 is going to be 0, because this is a graph of cosine, so I'm the graph of like the x points. Pi over here, the x-coordinate is negative 1. So pi, I get negative 1. And, whoops, this meant to be 3 pi over 2. So 3 pi over 2, which is over here, again, the x-coordinate is 0. The y is negative 1, but the x-coordinate is 0. So I'm back here. And 2 pi is going to be the same thing as the original, so that's an x-coordinate of 1. Right? And it's going to follow this shape even into the negative. So negative pi over 2, if you can kind of just see the shape, might even be easier. You can confirm it on here. Negative pi over 2 is right there. The x-coordinate's still 0. You kind of see the shape going. It should probably be going down. So at negative pi, you'd think negative 1, which is totally true because negative pi, the x-coordinate is negative 1. And then it's probably going to curve back up like the other side. So 3 pi over 2, negative 3 pi over 2. Right there, x-coordinate 0, so we're good. And negative 2 pi is the same spot as positive 2 pi, so we're going to be back up to positive 1. And again, if we just connect those points, we will have a graph of cosine. Right, see, I kind of bend it down. I don't keep going up from here because every value is between 1 and negative 1 and 1. So that's it, right? And that's essentially the lesson. It's really just graphing the parent function of these. And you just want to be good at that. So like I said, if you want to do it twice or however you see it, there's a slight difference, right? They look almost exactly the same. But the key is this one's has a high point as the y-intercept, whereas this one's y-intercept kind of goes through the origin. That is critically important as we go forward in this week. So it's a good designation to make. That's really it, though. I'm going to keep this one short because the other ones are going to be a little bit longer. So